Ní báyìí, ohun tá fi máa gbé yẹ̀wò, òun náà pè ní derived quantities. Lẹ́ẹ̀kan yẹn a sọ nípa fundamental quantities. Tí mo sọ pé they are basic independent quantities that do not depend on other physical quantities. Ṣùgbọ́n nísinsìnyí, a fẹ́ wo derived quantities. Kí la lè pè ní derived quantities? Derived quantities ni àwọn tí ò ṣe kí ni, àwọn quantities ò ṣe kí ni tí ò lè dá dúró fún àwọn. They need the support of fundamental quantities. But this is a combination of fundamental quantities using mathematical equations or mathematical methods. So, a máa ń fi fundamental quantities here, a máa ń combine papọ̀, la fi máa ń get àwọn derived quantities. From the word derived, a rí pé a máa ń rí láti inú nǹkan ni, àbí a máa ń rí láti inú nǹkan, a máa ń rí láti fundamental quantities. So, now, how do we define fundamental quantities now? They are the quantities that does not depend or that does not stand alone. That is, they depend on fundamental quantities. Mostly so it is a combination of fundamental. Now, so there's something you need to understand about physics. It has to do with your understanding. But as you don't have to copy everything word for word. Just get the basic understanding, and then you can implement that. You can come up with your own. That is why it's good for you to read several definitions, and then you can justify your own. You can author your own definition. That is how it's supposed to be. So now, this one is basic. This one is a simple understanding, a simple definition. So I know we can come up with our own, and then we can write that as we are writing our exams. We don't have to copy everything word for word. You don't have to cram. Just understand it. You can also the and then that's taking that's my cram me. Bye. Since they are not lost, they're just basic definitions. You can just derive your own, and then you get your answer. So far, the context of what you are saying is the same with what you have in your test. Now, so that there are quantities that does not stand alone. That alone is enough. All man depend on fundamental quantities. Lẹ́ẹ̀kan yẹn, mo sọ pé fundamental quantities mo fún àpẹẹrẹ wọn. Mo sọ pé length, mo fún ní mass, mo fún ní time, mo fún ní electric charge, àti bẹ́ẹ̀ lọ. Ṣùgbọ́n nísinsìnyí, a fẹ́ wo àpẹẹrẹ àwọn derived units. So, for example, then I'll fún ní area. Now, this is not straight to us. I'm going to put the area. But you can find area of a rectangle, area of this, area of that, area of a parallelogram, and the likes. So area gives us what? Length times breadth, right? Area gives us length times breadth. Abi and the mass, we know that it is noted as what? L times B, right? And then what's the unit of length? Is it what? Is a meter. That of B is also what? In meter. So M times M is going to give us what? M squared. So the SI unit of this is what? M squared. That's simple as that. The area of this is what? M squared. So it doesn't go not to name volume. You know, we are talking about volume, it has to do with 3D, 3 dimensions. That is, we have your length, you have your breadth, and you have your what? You have your height. Abi? Now, we have length times breadth times height. So, now this our length is in what? Is in meter also. So M times m, right, times m. And this give us what? MQ. So our SI unit for this is what? MQ. Meter cube. Now, so I repeat, is the combination of fundamental quantities. Now, if you notice from what I taught you earlier, Taba telling me that I repeat, we have m to be that of what? Length. Abi? So, but this is saying, I think combine metaphor on find derived quantities because they are gotten from fundamental quantities. So these ones are not fundamental. But they say that derived quantities are what? They are non-fundamental quantities. That's another definition, and then you get your answer. Now, you get your mark. So, that's fair or not. Let's look at density. Density is what? Is mass over volume. Only mass over volume. Now, most of our that of mass is what? Is in kilogram. And then we'll define mass form as what? As the amount of substance in a matter. With the software the bag cement. Abi? Also find only a mass. After in Abi? Is in what? Is in kilogram. So mass is what? Is in kilogram, right? Is in kg. And then what is volume? As it's a volume divided by what the finding m cube. And then that is going to give us kilogram per meter cube. Actually, we need meter per minus 3. I hope it's making some sense. All right. So, Eleka will mean. Eleka will speed. So, our SI unit here. SI unit is what? Of 1 kilogram per meter cube, or the same thing. So now let's look at speed now. What's the formula for speed? Distance over time taken. The distance covered taken over time taken. Now, the distance covered by a car can pay on Los Abuja. Distance here is now about, let's say, 50 kilometers. And then as you go to low on the speed. All these things here, all these formulas are very, very easy to know. So now the distance covered, but actually distance distance was what? Was meter, right? That is length. I felt at speed by of one that is meter, right? And then the time taken is what? Is seconds. Time. So I define time for you as what? As the duration of events. Akoko to low, abi? That's shape now over s. And it's going to give us what? Meter per second. I think they meter ms is per minus 1. So our SI unit here is what? Meter per second, or meter ms is per minus 1. So actually our mirror bẹ́ẹ̀ lọ. So actually ṣèwádìí kátó máa mọ̀ ọ́n sí. Now this is saying a fẹ́ wo fundamental units. Although it has been covered in some of this like only our SI units yìí, ṣùgbọ́n a fẹ́ wo fundamental units. So let me just give us a basic understanding of fundamental units. All that be derived units money. Units and our unity that provide. This one is a derived unit, right? This one is a derived unit. It's a derived unit because it's gotten from fundamental units. Is it making some sense? So it's gotten from fundamental units only because it's only from fundamental units. So I was doing it two simultaneously. So we have fundamental quantities, the quantity itself, this is area, is a quantity, and then the unit. So I was doing it two simultaneously. Now, what are the differences between fundamental quantities and derived quantities? So, on your by fundamental quantities and derived quantities. Fundamental and derived Now, if I'm going to ask you, the first thing that's going to come to your mind is that fundamental quantities are what? Are independent. The first one is that fundamental quantities are independent. That is, they can stand on their own. They can stand on their own. Why it is opposite for this one? They are independent. That is, they depend on fundamental quantities. They depend on fundamental quantities. So, then to give us an example, so we have length, we have mass, etc. We have area, volume, speed, etc. Àti bẹ́ẹ̀ bẹ́ẹ̀ lọ. So èkejì, these ones, fundamental quantities, they have their own SI units. Their own. To my fellow own, I can use the word personalized. They have their own SI unit. They have their own SI units. Why this one? They derive their SI units from fundamental units. Okay, we have examples here. They have direct calculations. Those ones, these fundamental quantities, we didn't calculate anything for them. Length is what? Is L. But it is the reverse for this case because we have to calculate their own calculation. We have to calculate their own. So they derive their, I can say their calculations are derived. So another one is that they are generally accepted quantities. They are generally accepted quantities. None of this one, they are just accepted. Just accepted. They are just accepted. Now, this is saying fundamental units. Fundamental units. So maybe I won't give us too much notes on this because it's similar to that of fundamental quantities. Just like what we did earlier, fundamental units are what? They stand on their own. So just give us something basic. They can stand on their own. They can stand on their own. For example, we have EG. We have meter. I'm just giving us both meter to be what? To be the unit of what? Of length. We have S, that of seconds, to be the unit of what? of time. We have kilogram to that of what? Mass in TC. Now, let's look at TC derived quantities, derived units, rather. Derived units. For derived units, now these ones are what? They cannot stand on their own. For the category and the examples under this, we have what? Meter square to be the unit of what? Area. We have meter cube to be the unit of what? Of volume. We have kilogram per meter cube to be the unit of what? Density. Àti bẹ́ẹ̀ bẹ́ẹ̀.